Section 6.4 is long division of polynomials. You've heard of long division before, you've used long division before, but now we're just going to transfer that knowledge to polynomials. If you remember what a polynomial is, we've been working them for a while now, it's different terms, variables of different exponents and things like that, all in one big piece. So this example says, think about the function, or think about the polynomial, f of x, which just means y, is equal to 6x to the third minus 19x squared plus 16x plus 4. If you know that x equals 2 is a 0, then we call x minus 2 a factor. Okay, we don't need to worry about knowing that. I'm telling you that information. Okay, so since the function is of degree, what is the degree? What is the definition of a degree? Okay, the degree is the highest exponent. So my highest exponent here is a 3. So this is of degree 3. The other factor, right, what is a factor? So a factor of 36, 4, and 9. Numbers I can multiply together to get that. So if I have something x to the third, I'm multiplying an x to the first, this guy right here, times something, x to the something, to get me x to the third. When we multiply variables that have the same base, what do we do with those exponents? We add the exponents and we multiply variables at the same base. So 2 plus 1 is going to give me a 3. So the other factor must be of degree 2. In order to find this other factor, we're going to call it q of x. We will use long division. The answer when we're talking about division is called the quotient. So q of x here actually represents the quotient. Okay, that's like the product is your answer in multiplication, the sum is your answer in addition, subtraction is difference, and quotient is division. So here's what we're going to do. I'm going to explain how this works. Okay, don't write this part down, or if you do, you might want to draw a little box over here because this is a separate example that I'm going to use to explain. Okay, so I'm going to do this over here just so we can see what we're looking into. All right, let's say that we had something like this. Let's say we had 12 on the outside of a long division box, and we had 1,492 on the inside. This is long division. This is the type of long division you've seen before. So let's think about this. Where's my starting process here? I start by saying 12 goes into 1 how many times? Well, it doesn't. 12 doesn't go into 1. It's not big enough. So I go to the next number. I slide over 1. I say 12 goes into 14 how many times? And my answer is 1. So if you remember, I put a 1 on top of the 14. Now what I do is multiply 1 times 12. So I multiply 1 times 12, and I put my answer right here. I'm going to perform an operation. I'm going to put that sign right there. What operation do I perform next? I'm going to subtract here. I subtract these two pieces. So I say 14 minus 12 is 2. I put a 2 there, and there's one important step I need. I need to pull down this next number. I need to put a 9 here. So now I'm saying 12 goes into 29 how many times? Notice I didn't go back up here. I went to the next number that was available. So 12 goes into 29. Think about it. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. So my answer must be 2. So I put a 2 on the top above the 9. And I'm going to multiply 2 times 12. And I'm going to put my answer right there. So 2 times 12 is 24. I draw a line. I subtract. 29 minus 24 is 5. I pull down this 2. And I say 12 goes into 52 how many times? My answer here is 4. 4 times 12 is 48. I subtract and get 4. And now I ask myself, 12 goes into 4 how many times? It doesn't. 12 is bigger than 4. It can't go any further. So my remainder is 4. It's okay if there's pieces left over. Alright, that's long division that you've seen before. So let's get into long division for polynomials. Okay, if I'm going to do this one, it says 6x to the third minus 19x squared plus 16x minus 4. Divide that by x minus 2, and then we're going to get rid of this last part here. So you can just cross out this piece right here. Alright, here's how I'm going to set this up. I put the x minus 2 on the outside of the box, and I put 6x to the third minus 19x squared plus 16x minus 4 on the inside of the box. We're going to do a method called far left and far left. So I'm going to take the number that's the farthest left over here and the number that's the farthest left on the inside of my box. Okay, so I put the inside of the box on top, 6x to the third, and the farthest left over here was an x. I put the x right there. I'm going to divide that. So 6x to the third minus x, or divided by x, excuse me, this really has an exponent of a 1. When we divide, we subtract the exponents. So 6 divided by 1 gives me 6. X to the third divided by x to the first, 3 minus 1, I get x squared. What I'm going to do with that just gave me my first answer. This 6x squared is going to go on top of the 6x to the third, because that was what I divided on the left. Now, just like in that example we just saw, I'm going to multiply. So 6x squared times x gives me 6x to the third. 6x squared times negative 2 gives me negative 12x squared. I line them both up, and what operation am I going to do here? Think back to the other long division. What operation do you do? We're going to subtract. Here's the tricky thing. I'm going to subtract both pieces, so notice that I put parentheses in here. In order to do this, I'm basically going to change both of the signs and then add, right? So I'm going to make this a negative, I'm going to make this a positive, and then I'm going to add. Okay, I distribute that negative. So 6x to the third plus a negative 6x to the third, that turns into a 0. Negative 19x squared plus 12x squared is negative 7x squared. Just like in that other long division, the next step, bring down your next piece. So I bring down the 16x. Now I use the method far left and far left. So here's my, well, let me get a different color. Here's my far left. It's an x still. Here's my next far left. It's a negative 7x squared. I go over here. I write negative 7x squared over x, my far left, divided by my far left. Negative 7 divided by 1, just a negative 7. X squared divided by x to the first. I subtract those exponents and get an x to the first. I don't have to write that 1 as an exponent. It's assumed. So I put that negative 7 x right up here on top of the negative 19x squared. And now I'm going to multiply. So negative 7x times x is negative 7x squared. Negative 7x times negative 2 is positive 14x. I'm going to subtract both pieces. So what I'm really going to do, I'm going to change the signs and then add. Okay? I'm really distributing that negative 1 through. That negative 1 is going to change the sign. So negative 7x squared plus a 7x squared, this becomes a 0. And 16x plus a negative 14x is 2x. These zeros right here are not an accident. That happened on purpose. That means we're doing our job right. Okay? That you want that to happen. What I need to do next is pull down the next piece. Pull down that negative 4. And I say to myself, far left and far left. So I have a 2x divided by an x. This is really a 2 over 1. That's a 2. This is an x to the 1, x to the 1. 1 minus 1 gives me 0. I don't even need to write an x there. So it's just a 2. I put a plus 2 on the top, and I multiply. 2 times x is 2x. 2 times negative 2 is negative 4. I subtract both pieces, so I change their signs, and then I add. And when I do that, I get negative 2x plus a negative, 2x plus a negative 2, that's just a 0. And I get negative 4 plus 4, that's also a 0. So this right here is actually my final answer. This is my quotient. There is no remainder in this case. I was left with 0. That means everything divided in perfectly. Okay, I'm going to jump ahead in the notes for a second, and then we'll come back and do some examples later. But I want you to flip to the part on the next page where it says important, and it's all capital letters or all bold and exclamation points. Because there's two things we need to do before we divide polynomials. And the first thing you need to do is put your polynomials in order of degree. Put polynomials in order of degree. From highest to lowest. So here's an example. You want them to look like this. Let's say you have 3x to the third plus x to the fifth plus 1. You want it to be x to the fifth plus 3x to the third plus 1. Because notice now x to the fifth, that's the biggest exponent. It comes first. The next biggest exponent is a 3. This has an exponent of a 0. So they're going in order from highest exponent to lowest exponent. The next rule is use placeholders. And let me explain what that means. You want to have every single exponent represented. It's not fair if you leave one out. So let's say there's an example that you're going to do, and it looks like this. X to the fourth plus 3x squared plus 1. I have an x to the fourth, but then it jumps to an x squared. Something's missing in there. What is it? An x to the what power? I'm missing an x to the third, so here's what I'm going to do. I'm going to write x to the fourth plus 0x to the third plus 3x squared, and I'm missing another piece in between the x squared and the 1. So I'm going to write plus 0x plus 1. So these are my placeholders. I want to have those terms so that everything lines up, everyone gets a fair chance here, everyone's represented. So I use 0. Multiplying anything times 0 is 0. So if I say I have $0, it's like the same thing as me saying I have nothing, right? So the fact that I put a 0x to the third, same thing as saying I have no x to the thirds, which is what showed up here. But you need these placeholders. So those are our two rules. Put your polynomials in order of degree from highest to lowest, and then use a placeholder. We're going to do plenty of examples when we get back. Please just make sure that you've watched this video all the way through and you have these notes filled out. We'll do tons of examples and make sure everyone's on the same page next class.